Okay. Excuse me. So the last video was over composition of functions. This one's going to be over inverse functions. So inverse functions are where the inputs and the outputs are swapped. So like the inverse function of some given function, you'd write a function like this. Let's say f of x equals x squared. That's the main function. What we're looking for now is what's called the inverse function, which you write with a little superscript -1 up there. And so the question is, how would you find an inverse function? Well, you can think of the function, f of x is like y. So that's my main function. If I want to find the inverse function of this function, one typical way of finding it is to rewrite the expression. But now I'll do a different color. I'm going to write where the y is, I'm going to write x. And where the x is, I'm going to write y. So I've just swapped the inputs and outputs. And now if I solve this new statement for y, which I can do by taking the square root of both sides, I will get that y is equal to the square root of x. And that would be my inverse function, would be the square root of x. That's one way you can find it. If you have the expression, you can just swap the x's and the y's and then get y by itself again. That'll get you your inverse function. What does it mean that this is the inverse function of x squared? Well, it means if you perform a composition, so if I do this of my original function, what ought to happen is you should get the multiplicative identity operator, which is 1. If you multiply by 1, we call it the identity operator because if you multiply anything by 1, you get the same thing back. So a times 1 equals a. Anything times 1 just gives you the same thing back, so it's called the identity operator. This one's to do with multiplication. Plus 0. 0 is the additive identity operator, because if you add 0 to anything, you get the same thing back. So that's what we mean by that. So if I perform the inverse function after I perform the function, well, f of x gives me x squared. So then what's the inverse of x squared? Well, I put that in where after I apply the function, I get x squared. And then when I apply the inverse function, I get the square root of that. And those undo each other. So I just get my input back. So I just get x. So I inputted x. The function turned that into x squared. When I put it into the inverse function, it does the square root, which undoes the squaring. And then I just get my original input back. I get x. So that's what we mean by inverse functions. They undo each other. And I could have done it in the other way. I could have done the function second and then the inverse function first. That would give me, the inverse function would give me radical x. And then if I apply the original function, which is squaring, I should get this, and the square root and the squaring undoes each other, so you just get the input back. So that's how that works. A little bit more information on inverse functions. So let's say I've got x squared, So 0, 0, 1, 1, 2, 4, and then 3, 9. X squared is symmetrical. So this is my x squared. Well, let me write that with the parentheses. There's my function, and I'll sort of write the points. We have 0, 0. We have 1, 1. We have 2, 4. And then you have minus 1, 1, minus 2, 4. The y values are just the square of the x values. Now, it's always the case that the inverse function, if I do sort of a y equals x line, so it's like a 45-degree angle, mirroring across that line, you will always, that's what the inverse function is. So if I just take those points and I rewrite them, so swapping 0 and 0 just gives me 0, 0. Swapping 1 and 1 just gives me 1 and 1. But swapping 2 and 4 will give me 4, 2. So it sort of mirrors. And then swapping the x and y. So so instead of minus 1, 1, I'm going to switch those to make it 1, minus 1. So at 1, you have the minus 1. And at 4, you also have minus 2. So this is kind of like, and this is always the case, that because you're swapping the x and y, I don't know how to show you. Let's say this is my picture of my graph. Some graph where the vertical is the y-axis and the horizontal is the x-axis. Well, I'm going to take the x-axis and point it up with the y-axis running off to the right. So if you take your graph and you kind of flip it and then rotate it, just like how this parabola is sort of on its side, that's how inverse functions always work. Now, normally we would call this this no longer passes the vertical line test, so it's no longer a function. But we could call the top one, well, I'll call this the inverse of it, and that is square root of x. The one underneath is actually minus square root of x. Usually, if we're just talking about the square root of x, we're talking about this principal one. So we're just talking about the top half of this curve, just so that it is a function. If I have two parts, then it's not a function. But these two bits together will make a parabola. So you could have a line. So here's a line, and let's say it goes down like this. So it has a slope of -3. Every step it loses 3. So it'd be at -6 at 2. I'm sorry, -3. It drops 6 altogether. So that's the function. We can say that that is equal to, what is it, 3 minus 3x. So every step you lose 3. Okay, well, let's find the inverse function. Well, I know what it's going to look like at 0, 3. So instead, we're going to have 3, 0. At 1, 0, we're going to have 0, 1. And at 2, -3. So that means at -3, we're going to be at 2. If I drew that well at all, I mean, my spacings aren't very good, but it would look like this. And again, I'll use a green line. Everything's sort of mirrored across this line. That's how you get the inverse function. what is that function? Well, you can kind of figure it out. It has to go through 1, and it drops 1 point in 3 steps. So you could figure that out. But you can also do that like we did before, call this x, put the y where the x used to be. You're flipping your inputs and outputs, and then solve for y again. So I could add 3y to both sides, and then subtract x. So I would get 3y is equal to 3 minus x. And then I will divide by 3 everywhere. And so my function, my inverse function, is going to be what y is, which is, this is 1 minus 1/3 x. All right. So again, if you have, now just to test that these are inverse functions, we do a composition. So f and f of the inverse. If they are inverse functions, I should just be left with x. So it doesn't affect the input. So this is my input, and once it goes through these two, anything that one of them does should get undone by the other one, so that you just have x again. That's how you know that they're inverse functions, that they do the inverse of what one another do. So if I apply the inverse function first, I get, I'll get f of 1 minus 1/3 x. And then I apply what the function is, which is 3 minus 3 of the input, which is now this. It's now from what the other function did. So if I figure all this out, hopefully I get x. So 3 minus 3, that makes 0, plus x, yeah, I just get x back. So these are inverse functions. That's how you check them. You do a composition. You may get, let's say I have a function 0, 1, 2, 3, and let's say the outputs are, I don't know, 7, 9, 11, 13. Okay. Well, what do I know about the inverse function? Well, I know it's going to be swapped. So if I have 7, 9, 11, and 13 as my inputs, I will get as an output 0, 1, 2, and 3. It has to be because if, let's say you have 2 and it goes through the function, that gives us 11. Well, then the inverse function needs to take 11 and turn it back into 2. It needs to undo what the other one did. So you know from a table some of what the inverse function needs to look like. If you have an expression, you can swap the x and y positions and then get y by itself again, and that would give you the inverse function of the original. And if you have a graph, I don't know, whatever your graph is, just find that line, swap the points. So this would, I don't know what I'm doing here. All these points would get swapped to here. I don't know, something kind of like that. It's always going to be the mirror image across that line. And you just find the point, like maybe this is like 3, 5, I don't know. So then you would go to 5, 3 to find its equivalent point, or its analogous point. But that's inverse functions. You can check to see if they're inverse by doing compositions. And yeah, I hope that made some sense, and hope you guys have a good rest of your day.